So this is 7th grade, Unit 1, Lesson 10. What page is this? Looks like it's page 83. So talking about scale drawings.
What group were you from?
I didn't tell a group to erase
Oh,
points.
if I heard something.
So it says if a student uses a ruler like this to measure the length of their foot, what choices would be appropriate measurements? And it says select all that apply. So let's take a look at this here. 9¼ inches. Well, this doesn't go to 9 inches, but it would be easy to figure out where a quarter would be because this, so for example, right here, this would be 2½ inches. And then halfway between that would be 2¼ inches. So I think 9¼ inches would work. 9 5/64 of an inch. Yeah, that's not going to work. You can cross that one out. And then centimeters. Well, here's the centimeters. And you guys should know by now that when we're looking at a ruler and it has the centimeters, each one of these, so for example, between 2 and 3 here, each one of those little tiny marks would be considered a tenth. So for example, the last mark right before the 3 would be 2.9 centimeters. And the first mark right after the 2 would be 2.1 centimeters. All right. So here we have C. It says 23.4765 centimeters. That's not going to work. It's going to...
It doesn't even exist.
No, well, it does. But certainly not on a ruler or the scale they give us here. 23.5, well, it'd be easy to mark the halfway distance between a centimeter. So, for example, 7.5 centimeters would be right there, 7.5 centimeters. So 23.5, I think, is definitely doable. Last one, 23.48. Well, if you were allowed to round, you could just call it 23.5, but 48 would not be very practical. So I think I'm just going to scratch out E. Okay. So turn the page. Now this is something we already did as far as measuring. So we randomly picked 5 students, measured their approximately the length of their feet with their shoes off, and 5 students ended up being 45 inches long. So approximately, again, that's what that little symbol means right there, approximately 9 inches. So we'll say that's the average length of a 7th grade student's foot. Okay. So it says here's a scale drawing of an average 7th grade student's foot. This is the one they're talking about here. To a scale drawing foot, to a foot next to a scale drawing of a foot belonging to a person with the largest feet in the world. It says estimate the length of larger foot. So here's what we would do. First off, you have to realize this would be 9 inches. So if that's 9 inches, the question is, how many inches would this be?
11.
And probably the best way to do it, you could use a ruler, or if you have a protractor, and everybody should have one. Take a look at this here for a second. So it looks like if I went with, okay, don't get those right now. Just hang on. Sit down, please. Nope, sit down. Nope, nope, sit down. Thank you. All right. Shh. This is a little over 5 centimeters. Inches wise, this is just about exactly, as you can see here, 2 inches. And if we were to measure this in inches, looks like it's just exactly 3 inches. So I'm going to put a little 2 inches right here and underline it. And I'm going to put 3 inches right here and underline it. So how much larger is this one from this one scale wise? Yeah. What do you think?
One-
It's 1 inch larger, but what would that be on a scale? How much larger on a scale? Mr. Sortelli, what are you thinking?
1.5 times bigger.
Yeah, it's 1.5 times larger. So this is 1.5 or 1.5 times larger. Okay. So if you needed to figure out the largest foot in the world, what would you do with the 9 inches? We don't know how big this one is. We need to figure it out. But we know this one is 1.5 times larger. So let me pull a stick here and see if for 10 points. Oh, I already called on Mr. Sortelli. Mr. Sortelli actually put up 20 points for answering that question. Miss Sanders, what would we do to figure out the size of the largest foot in the world? Any idea?
9 times 1.5.
Yeah, it's nicely done. Put up 20 points. So it's going to be 9 times 1.5 equals something. And I'll let you guys figure that one out to answer that question. Okay, nicely done. All right, I put a line through the bottom of page 84. Not going to worry about that. And then I put a line through the top of page 85.
Isn't there something?
Okay, is that the time to be going over this when I'm recording? No. So erase points. But you did do it. Thank you. And if you want to argue with me, we can have you erase more. All right. So bottom of page 85, it says, are you ready for more? So it says, Noah and Elena each make a scale drawing of the same triangular. Oh, I put a rectangular plot of land using the following scales. Make a prediction about the size of each drawing, how they would compare to the scale drawings made by your group. Well, so this is Noah's drawing right here, and you might want to copy this. I'll zoom in a little bit for you. Okay, it was a triangle, and I already addressed that I used a rectangle. So, so this is 2 centimeters long from here to here. If it's 2 centimeters long on Noah's scale, how long is this plot of land? 400 meters. This is 1 centimeter from here to here. And if it's 1 centimeter, well, they give it to us right there. It's then 200 meters. So the actual scale of Noah's drawing, 1 centimeter to 200 meters, this represents that. So Elena, she uses a scale of 2 centimeters to 25. Well, so for every 2 centimeters, that represents 25 meters. Well, if we needed this to represent 400 meters by 200 meters, how many times does 25 go into 400? What do you think? Mr. D. Woody, you had your hand up. What's that? 16 times. 25 goes into 100 4 times, 200 8 times, 300 12 times, and 400 would be 16 times. Okay. Well, what's 16 times 2? 32. So her representation would be very long. It'd be 32 centimeters long. Well, I don't have, actually 32 centimeters is not going to fit in the workbook. And from here to here is 10. That's a good ways across the page. And then that'd be another 7 right there. So we're already going off the page. So it'd be quite a bit larger. So, and I think you could just write down number 2 would be much larger. Okay, that's what I'm looking for. Turn to page Number 86. How am I doing on time? 10 minutes. All right. Here's a scale drawing of a playground. It says the scale is 1 centimeter to 30 meters. So just so we're all on the same page here, 1 centimeter is 30 meters. We can measure this B here, and let's just say it's looks like about 3.3 centimeters. So if I wanted to know the actual length of B, it would be 3.3 times 30. All right. So it says make another scale drawing of the same playground at a scale of 1 centimeter to 20 meters. So it would be 1.5 times as large. I don't want you to actually do it. It will be 1.5 times larger. All right. And we kind of answered number 2 here, which is how do they compare? Well, the second one would be larger. But here is what I want you to do. Now, make note of this because they don't ask you to do it in the book, but I am asking you. I want to know, and you could write it down this way, A equals, B equals, C equals, D equals. I want to know how many meters each one of those sides are. So you make sure you answer those questions there. Then they have the lesson summary. Talked about summaries many times. They're not asking you any questions, but they do give you good examples to think about if you're not sure you understand the scale lesson. Practice problems. So I'm on page 88 here. It says, here's a scale drawn of a swimming pool where 1 centimeter represents 1 meter. Well, how long and how wide is the actual swimming pool? Well, I'll take my protractor. How many meters is it across the top, for example?
Oh, wow. Whoa.
Little more than 10.
That's like maybe like.
Yeah, I'm gonna keep it easy here. It looks like it'd be about 10 and a half. I'm gonna put 10.5 centimeters. So if across the top, and this is a rectangle on the bottom, if that's 10.5 centimeters, how long is the actual pool? How long is the actual pool? This scale right here, this is 10.5. Times it by 2? Why do you think it'd be times by 2?
Because if it's it says for question 1, here's a scale drawing of a swimming pool where 1 centimeter equals 1 meter. So that means it would be 10 meters, 10.5 meters. So it would be times 2 because it's a scale drawing and it's going to be much bigger.
You have the right idea, but you took it too far. 1 centimeter represents 1 meter. So if I looked at 1 centimeter, that would be 1 meter. 2 centimeters would be 2 meters. 3 centimeters, 3 meters, and so forth. Well, we go all the way to 10.5, so the length would be 10.5 meters. Okay? 10.5 meters. So you need to figure out, it says how long and how wide. So the wide, I'll let you guys figure that out. Okay? Then it says to make, okay, you can answer B, you could do C, and number 2, and I'm almost out of time here, darn it. And that's it. That's actually, there isn't very much as far as homework or classwork. So write this down. I want you to do pages 83 through 89 and the Get More Math, which I'm going to go over that with you in just a moment. 83 to 89. And I'm going to end the video because it's about to end anyways.